And the application I will be building today is the application to help me count how often do I drink tea. So I have this cup, which is also on the slide, and I want to be able to detect whenever I drink tea. Like this, it will detect it. So it will tell me at the end of the day that I have done 154 sips of tea. And also, it would be nice to detect when I am present in front of the computer. So whenever I go away, I want this application to detect it as well, so that at the end of the day, it can tell me you've been in front of the computer, you've been working 64% of the time, and you drank so much tea. So that's the final goal. Yeah, that is the final goal of the application. Actually, today we'll be building only the AI part of the application. We will be building the part that will detect the cup and that will detect me present in front of the computer. And the rest, like counting, it's additional application logic which you can put afterwards. So to do this, how we will work? Because it's a workshop, you are supposed to do something by hand yourself. We will be going in like small parts. First of all, we'll start by installing Lobe AI, and that will give you some time to do that. And then we'll proceed like bit by bit. I will show how to do something, and in case you are stuck, please feel free to ask any questions. And you can ask questions here in Teams, or you can ask questions in Discord, because we have two places where you can ask questions. Actually, Teams may be more convenient for now, but if you want to continue working on this application, if you want to continue staying in touch with all other students who are taking part in Imagine Cup, this Discord is a great place to do it. So the sooner you get to Imagine Cup Discord, the better. And to get to the Discord, you should register for Imagine Cup, and you will have the link to Discord in your Imagine Cup profile. So today, let's start by installing Lobe AI. So Lobe AI is the application, and you need to download it using the URL lobe.ai. So you go to lobe.ai, and it will have this button download on the screen. So that is something you should press, and you should start downloading it right away. And meanwhile, there are two other things that you can start doing. First of all, start thinking about what kind of application you can build with Lobe AI. So again, Lobe AI will allow you to detect different kinds of images. And you can see some examples here on the side. For example, recognizing different plant species, recognizing hand gestures like 1, 2, 3, 4, 5, or recognizing different poses during physical training, recognizing emotions, and so on. Many, many different ideas that you can think about. And today, I think it's good to think of a problem which has something like 2-3 classes for which you can easily obtain images. As we will see in a moment, you would be able to, well, to train the model, you need images. You need to provide it with images to train on. And those images you can get from your web camera, from Lobe application, or you can get from somewhere on the internet or from your photo archive from somewhere external. So think about different kinds of images that you might have, and think about some problem that you might want to be solving today. If you cannot think about something, you can solve like gestures, 1, 2, 3, 4, 5, or thumbs up, thumbs down, those different kinds of things. But yeah, think about something and install Lobe AI. And let's see how much time will it take you. I guess like I should give you something like 5 minutes to install it. I will not do it myself because I have already done it. But yeah, you need also to provide your name and email to download. So please go ahead and do it. And meanwhile, while it's downloading, while it's installing, you can type in the chat like what kind of ideas you have what do you want to build today? Any original ideas? Let's start by this small exercise and sharing your ideas. Like what can be done, what interesting can be done using image classification. So feel free to type something in the chat. I hope that all the participants can type in the chat, right? Or you can also type in Discord. Is a great question. Can movement recognition be possible? So right now with Lobe AI, that's not possible. Lobe AI is just the beginning. So it is something which is being actively developed, and right now it supports only one problem, which is called image classification. So it means that for each image that we give it, it will classify it into one of the several classes. Soon it should support object detection, and object detection is something which can recognize object inside the picture and essentially like create a bounding box around it. That is something that I showed on the slide before. And once we have object detection, we can detect movement because we can detect how this box moves across the picture. So that is something which will be there in the future. But if you have an idea around object detection, we have another tool which is called custom vision, which I will talk about briefly at the end of this session. And you can use custom vision to train object detection model. So anyone had a success installing Lobe AI so far? I guess not. So I will wait a little bit more. Done. Great. Excellent. So let's wait a couple of more minutes for people to install Lobe AI. And if you have any questions, let us know. And again, if you have any ideas, please share them as well. Let me start by sharing. Well, that's actually not my idea. I wanted to say, let me start by sharing my idea. I have shared already one idea, but there is also one well-known project, a cat feeder, like an application which will detect a cat that walks to the kitchen, and it will open the the tray with food or push out a piece of food for the cat as soon as it sees a cat. And yeah, that is, and for example, not for a dog. Or you can use it like if you have a yard and you have some kind of animals going in, you can detect animals. In the place where I live, by the way, I live in the apartment, which is like higher floor, and I can see ships flowing in the small canal. So I wanted to create an application that will, make a sound each time it sees a ship, so that it can look out of the window and also see it. That is a good example of using Lobe AI as well. So I guess you should probably be done installing for now, at least those of you who follow. So anyone apart from Harsh had any success installing Lobe AI or any problems? No. Okay. Let me start it actually and see what Lobe AI can do. Why do we love Lobe AI so much? Okay, somebody has a problem with installing Lobe AI. So let me know what kind of problem are you experiencing with installing Lobe AI. I was told today, by the way, by Jim that Lobe AI has some problems with Macs, non-Intel Macs. So if any of you have non-Intel Macs, then you might indeed experience a problem. So once you installed Lobe AI, you can start Lobe AI, and this looks like a challenge because you see I started it and it's still starting, so it takes a little bit of time to start. That is the second part of the challenge. Start Lobe AI. Good. So you see Lobe AI, it's the client application, and okay, yeah. So somebody is saying it's crashing on M1 Mac. Unfortunately, that is the problem. Yes, indeed, it's crashing on M1 Mac. So if that is the case with you, unfortunately, you will not be able to use it at the moment, and you can hang in here just to watch how this can be used. Or at the end of the workshop, I will mention also Custom Vision, which is a web-based tool. It's a little bit more complicated, not as user-friendly, but you can also use that to solve your computer vision problems. Yeah, and the second problem is Lobe currently requires CPU which supports AVX instruction set. And I believe that is also something we cannot easily fix because AVX instruction set, I believe it should be available on the modern processors. But if you do not have it, then I guess that's tough luck again. And yeah, hang in here to watch the demo or come back towards the end of the workshop to talk about custom vision. So the way Lobe AI works, it's a custom application, and here you can start a project. So let me start a new project, and essentially what you need to do, you need to get images from somewhere, label them. Label means classify them into several classes. And then it will automatically train the model, which you can then export to different formats. So the great thing about Lobe AI is that it gives you the model which can be used in mobile application, which can be used in web application, which can be used everywhere. So the first thing that you should do is to collect some images, and you don't need a lot of images. You see, it says here 5 images per label is something you need to start training. So 5 is probably a little bit too low, but having 10 to 15 images per label is quite good. So think about different scenarios that you will have, like detecting hand gestures, detecting different emotions, and try to get some images labeled. So you can, what you can do here, you can import images, and you can import them from images on your computer. So if you have them available in the directory, you just import. You can import them from camera, or if you have them in the folder already, like within folder structure. So for example, if you have cats and dogs, and you have separated cats and dogs into different folders, then you can easily import a data set. So for fun, you can use the camera. Let's see if I can use the camera, because my camera is used for presenting, but I have 2 cameras, so I can use second camera. So here, for example, what I can do, I can take this image, and then I would need to label it. So I can say I should have labeled it before. So let me Let me start again. So I say I want to import images from camera. I put the label no cup. And I take different images with this no cup label. And then I can give another label cup. And take several images with the cup. More than 5. And I also should take more images without a cup. So I will go to no cup again. And take a few more. And then I would also take a few images of the empty space. The last one was not good because it was not empty, but anyway. So that's how you should collect your data set. You can do it either from camera or you can import it. As I mentioned, you can import it from the folder on your computer. So take some time to do that. And let me know how it goes. Like type in the chat, we have collected 20 images, or like we don't know what to do. We don't have any idea, in which case we will help you create one. Okay, so let's collect some images, and I will give you like a lot of time, 5 minutes to do that, maybe even 7 minutes. Let's take 7 minutes to do that, because that sounds like the most interesting part. You need to find good, interesting images. And by the way, if you want, you can also get images from somewhere. So for example, there is this thing called cats and dogs data set. So you can download cats and dogs data set from Microsoft website. And it contains something like, I don't know, 5,000 images for cats and 5,000 for dogs. So that's one of the possible things you can use. Of course, you don't need 5,000 with Lobe. You need something like 20. I will paste the link to Discord because for some reason I cannot copy this link to Teams. So for some reason I cannot use chat in Teams. So that's another reason for you to switch to Discord. But the good thing about Lobe AI is that it allows you to do it in a fun way. Like, you know, taking pictures from camera sounds like fun. There is, of course, one problem with this. If you train any computer vision model, you should provide very different examples. So if you want to train a model which will always detect like people with cups, you need a lot of different people with different cups. You need lots of different images. And if you are taking them just from camera, you are creating very limited model. So the model that I will create today, which detects me and my cup of tea, will only be suitable for me sitting in this very location and not for anybody else, because the model has no way to, like, if you have only few images, we don't know what the model looks for. For example, the model could look for the word geek instead of the cup, and if I show it a t-shirt with the word geek, it can also think it's a cup. So in order to avoid this, we need to show it like different things. Like we should take a person with the t-shirt with the word geek and say it's not a cup, and then we should have a cup without any letters and say that it's a cup, so that the model has a chance to learn what is actually important for classification. So while we are doing that, I want also to remind you that we have the workshop at this repository. So if you go here, you can see all the instructions on the GitHub as well. And we actually skipped a couple of pieces here, but we'll come back to them in a moment. So right now, what we are doing, we have obtained Lobe AI, and we are providing the data for our model. So we are somewhere in the step 2. And soon we will hopefully have our model working. Anybody has a success with images? You know what you are doing. I see one person is doing something actually. Harshita is doing something, which is great. Okay, we have still 2 minutes to the promised time. So in 2 minutes, we will proceed with training our model. Actually, what happens now is that Lobe AI trains our model in the background. So whenever we add one image, you can see that this train flashes a little bit, and the model, as soon as it gets new images, it started training in the background. So it kind of tries immediately to distinguish between different images. And you can see that here it says 96% correctly and 4% are predicted incorrectly, which is like not too bad, but yeah, not too bad for the small amount of images that we have. Okay, anybody else apart from Harshita and Harsh are doing something? So should I wait a little bit longer, or should we continue? Okay, let's talk about next steps about training and using our model. And if you are still collecting images, well, you will have some more time shortly to do that. So as I mentioned, the model is already training, and if we switch to train, you will see like which examples it actually predicts incorrectly. So the model takes small number of images as a test data set, and it does predict some of them correctly, but some of them are not correctly. So what we can do, we can look at it, we can try to add some more images, we can try to change some images and so on. And then the most interesting thing here is use. One thing you can do, you can start using this model right away in Lobe AI. So for example, you can see that this model right now is predicting no cup. If I take a cup, it starts predicting cup. Not immediately, like it has a short delay because it takes some time for the model to run. But otherwise, it seems to be working, right? So as soon as I get the cup here, it starts showing cup. And what you can do here, you can try, detecting some of the images which are recognized incorrectly, and then you can take them and add them to the data set. So this is a good way to enhance your data set while playing with the model. Because like the more different images, incorrectly classified images you give it, the better would be the model quality. Then you can also use this model to predict on images, like you can drag and drop images here and see what's the result of classification. But most importantly, of course, it's not fun to use the model only in Lobe AI, right? So what you want probably to do is to use that model in your application. And you can do that using many different ways. Like the most frequently used ones are here on top. Like one of them is Lobe Connect. Lobe Connect is when you are running Lobe locally on your computer, you can use it as an endpoint, as an API to do predictions. Like suppose you want to classify your family album into portraits. Like if you have a folder with photographs, you can classify it to portraits, landscapes, and like some objects, environment, and so on. So if you want to do that locally, you can write a script which will call this Lobe AI locally and do the classification for you. You can also embed this model into a web application using TensorFlow.js. TensorFlow.js is a library which runs inside the browser. So if you have the client application, client web application, TensorFlow.js is the way to do the image classification right in the browser. And you can also export it to other formats like Onyx or NNX, this one. Onyx is a great way to use any machine learning model in .NET applications, or essentially in many different runtimes. So Onyx is supported by really a lot of different libraries and frameworks. And yeah, TensorFlow Lite is good for mobile applications. So you have the range of different options how you can use the model. So one thing, like what we will be doing today, we will create a web application which will do the classification for us. So here, what you can do, you can say, I want to do web app, and it will open you the web repository with the example web application, which you can tweak to your own needs. But for us, like what we will do in our workshop already has the sample web application. So what you will need to do next is to download this, to clone this workshop repository and try running this web application to see if it works with existing model. So not with your model right now, because your model, we have just trained it. But let's make sure that you can get the model working on your computer locally. So all the instructions are available here. So if you start reading the workshop, it says start by forking and cloning the repository. So what you can do, you can fork this repository to your GitHub, right? By clicking fork here, and it will create your own copy. So if you want to modify it, if you want to add something to this application, by all means, fork it first and use it as the start code. If you just want to play with it, you can clone this original repository, and that would be fine as well. So clone it, and then you would need to install a couple of things like Node.js and Yarn, because those are tools that are used to run the web application. And you should be able to run the application which is contained here in this repository, here in apps web bootstrap. So this application is essentially similar to the one we have seen before. It's the starter application to use Lobe AI. So that is kind of complex task to do. Clone the repository or fork and clone, and then install the tools if you don't have them. So it will require Node.js and Yarn, and run it. This workshop has some hints on how to do that. So if you go to run the app, it tells you like how to do it. So how to install Node.js. You should do Yarn install. You should do Yarn start, and that's it. You are ready to use the application. So let's do that first, and then as the final step in our bootcamp, we will connect our model to this application. But first, let's get the application working as it is. So that probably will require you to spend a little bit more time. So please start doing that and let us know how you are doing, and or if you have any questions. Okay, so somebody is having issues with Node.js. That is possible, but yeah, maybe you can try like installing it or reinstalling it or something like that. That's also a good introduction to how to do web applications in general. So how to run Node.js application, and then we'll also discuss a little bit how to host this application in the cloud. So if something doesn't really completely doesn't work for you, that's fine. Like you can of course just go ahead and watch what we are doing here on the screen, but that is not nearly as much fun as doing it yourself. That's a pity that my application is not running. I do not know how many times I drink my tea while running the workshop. Yeah, Node.js is like all the modern languages like Python and Node.js, which has a lot of libraries. It's very tricky to have all the versions come together correctly. So it's easy to mess up things and it will stop working. I share the pain. So is anyone trying things? Like, how is it going? Let us know in the chat, because we don't want you to be bored. We want you to be productive and doing something nice. Yeah, we can share the link to the repository. Sure, I think I have shared it in the beginning in the chat. It's also shared in the Discord. And I'm hoping that Jasmine will share the link to the repository because for some reason, I cannot write in the chat in the Teams meeting. I have no idea why. Thank you. Thank you so much, Jasmine. So essentially, not to keep people bored, I will probably also start doing something as well. So here, here to start working with Git, probably it's good to use command line tools. I don't know if you prefer command line tools or you prefer interface like UI to Git. Because there are different styles of working, like for example, tools like Visual Studio Code contains Git UI, and you can use GitHub from there, or you can use command line tools. I personally like for cloning. For some reason, I like using command line. Okay, I will just use some directory here to experiment with. So first of all, I need to clone this whole repository. So I start with the name of the repository, like the Microsoft/Hack Workshop Lobe, and I do git clone. So what it does, it essentially takes the whole copy of this repository and downloads it to my computer. If I clone it like this, it means I don't want to make any modifications. Like I just take the code and I want to play with it and throw it away. If you want to like start improving this project and evolve it into something like new, but starting from this code, you should fork it first. So forking it first creates your own copy of the project on GitHub. Like it will not be Microsoft/Hack Workshop Lobe, but it would be your handle/Hack Workshop Lobe. And you can clone that. You can clone your own copy, and in which case you would be able to contribute back and change the code and like play with it as much as you like. I mean, play and commit it back to GitHub and make it available to the world. But just for the reason of for testing for the workshop, you can just clone this one. So we have now this Hack Workshop Lobe directory. We can go there, and here we have apps, exports, goals, directories. So application is in the directory apps. So we can go to apps and then web bootstrap. That is our web application. You see it contains like license, README, assets, and so on. And this web application is a Node.js application. And it uses Yarn for package management. So any complex Node.js web application uses some libraries, like some external libraries, and you need to be able to like keep all the versions up to date, take into account different dependencies, and so on. And that's why you need package management. And there are essentially in Node.js world there are two most frequently used options: Node.js and npm and Yarn. And this one uses Yarn. So Yarn, the first thing you need to do Yarn install. And what it does, it fetches all the packages from the internet so that you can use them in your application. And that might take some time. So if you have any questions while we are waiting for the packages to get downloaded, let me know. It's a pity we don't have the prize for the best question. That's why we don't have questions probably. And we should also have the prize for the best idea how to use Lobe in Imagine Cup project. But by the way, I think we do have the Epic challenge. You can think about the best way to use Lobe AI in your Imagine Cup project and take part in Epic challenge and get the prize, right? Aha. My mentoring session. Morgan suggests that my mentoring session would be a really good prize. That is maybe correct. So if anybody suggests the great idea to use Lobe AI in your Imagine Cup projects, then we will discuss it further in the mentoring session. That's a great way to do it. I wonder if that sounds like a good prize or not. Okay, anybody is also waiting for packages download? Is anyone lost? Let us know. So let's explore a little bit the structure of this web application, and I will show it on GitHub because that's probably easier. So apps web bootstrap contains the web application. And here you can see that this directory src source, that's the source code for application. It has the CSS file. It has a few TypeScript files with the main application, Node.js components. So that is the code of the application in source directory. And then there is also directory public, which contains the model inside this public. So there are a few things like index.html, the homepage, and there is also a directory called model. So this model contains a few files. Model JSON, signature JSON, and a few binary files. So that is actually the trained model, which can be exported from Lobe AI. This repository contains some existing pre-trained model, and we'll see what it does in a moment. But let's look inside, like model JSON, what it is. Not very pretty. So that's a JSON file. Let me try to beautify it a little bit. How can I beautify it? It's not much more beautiful, but you can probably see what this file does. So this file describes the way the neural network for image classification works. So that's TensorFlow.js file, which describes which layers the network has, what is the size of the layers, so all the details of the neural network structure. And you see it's pretty big. So what Lobe AI in fact does behind the scenes for us, Lobe AI trains a neural network for us. And that is the structure of the network, mobile net, actually, you can see. And signature JSON is also like simple file which describes different. It describes essentially the classes that we have. So you see here there is this classes part which says label, none, thumbs up, thumbs down. So in fact, the model describes different gesture recognition. So thumbs up, thumbs down, and none of those. So this signature JSON essentially contains the classes that our model uses. So that is the model. And if we want to place our own model, we just need to replace this model directory in this application. So let's see whether it has finished. It has finished installing all the packages. So now we can say yarn start. So this application is a little bit complicated, as you can imagine, because it is Node.js application, so it has some server side, and it's also a React application on the client side, because the model actually runs in the browser. It's TensorFlow.js model. So the main work, the gesture recognition, happens in the user's browser. First time the application starts, it takes quite some time to do it because it compiles. It has to compile all the scripts, including the libraries which it uses. And that's why that's not very fast. So once it's done, it starts the web development server locally on the port 3000 and opens the browser. And again, for the first time, it takes some time because you see it says starting development server. So it takes some time to start it. That's why it doesn't show immediately. So while it is starting, any problems that you are experiencing, anything not clear, let us know. And even if everything is super clear and you are very happy, also let us know, because it's nice to get some feedback from you to see that, you know, we are doing the right thing. I assume we should give you more time to work on the workshop because you see, even on my super fast computer, it takes so much time to run the Node.js application. That's why we need the power of the cloud, you know, because on the cloud, it's much faster. We have powerful computers on the cloud. Yeah, thank you. It's nice to hear that we are doing fine and that you are not bored and that you are also running the same thing. That's good. Okay, you see now it tells me that files are successfully emitted and my web application starts. So now it should probably start soon. I guess what could be the problem here is that this web application needs to access the camera as well. And I have already a lot of applications using my camera. No, still it works with one of the cameras. Now it's loading the model. It takes a little bit of time to load the model because all models are sometimes they're getting big. And you see now there are no gestures. If I put the thumbs ups, it will tell me that is a thumb up. Not very sure, but yeah, if I do thumbs down, thumbs down. Now I'll try to confuse it. A confused network. So that is kind of web application that we have out of the box, right? So this is something we have not done anything. We have just started the application from the repository. I will stop it. And I will stop the server here. Good. So now what we need to do, we need to take our model from Lobe AI and put it in the right folder in the application. So I will probably give you a little bit of time to try to do that yourself. Right, so here you need to use TensorFlow.js and export it as TensorFlow.js model and put into the right folder in this sample application. Try to do that, and I will be back in, let's say, 5 minutes and check how you are doing, and we will do that together as well, but try to do it for yourself. If your Node.js server is still running, like, you can export the model to another directory meanwhile, and then you will replace files. By the way, was anyone able to run the application? I wonder if your computers are fast enough to do that. Or is it just mine which is that slow? I probably have a lot of things also running in parallel because I do the Teams meeting and Discord and Lobe AI and a lot of tabs in the browser for some reason. I'm really anxious to see a lot of people are typing at the same time, so probably something interesting is going on. Okay, somebody's got the application running. That's great to hear. Thank you. Okay, let's wait 1 more minute. Actually, 2 more minutes. I promised 5 minutes. Any questions meanwhile? I'm ready to answer them as well. So a few words, like, while you are doing your work, a few words about how this Lobe AI works behind the scenes. So to make image classification, typically we use something called convolutional neural networks. And convolutional neural networks are networks which learn how to capture different patterns in the image. So for example, if you train this network to classify between cats and dogs, it will try to capture, first of all, some low-level patterns, like the cats probably have whiskers and they have different eye patterns. So the network will look for those patterns, and then it will put those low-level patterns together to form like higher-level typical outlines of, for example, ears of a cat or like whiskers or eyes, and then like put that together to detect the whole head and the whole cat in the picture. But to train such networks, you need really a lot of images. So what Lobe AI does, it trains the network on, like pre-trains the network on many thousands of existing images, because there are large data sets like ImageNet out there. So it trains the network on those data sets, and network learns to recognize different typical patterns. So typical for like those objects which are present in the data set, which are like many different classes. ImageNet dataset contains thousands different classes, so several species of cats, several species of dogs, and many other objects. So the network learns about all those patterns, and then when you provide just your few image categories, in fact, it looks in the images, it looks for existing patterns, and then sees which of those patterns fit your categories. So this is something called transfer learning. So we transfer the knowledge from other data sets to your data set. And that's why your data set can be so small, because it doesn't learn from scratch. It learns from other data sets. It learns from existing patterns and just applies it to your problem. A great question in the chat from Atesh. Can we use Lobe AI for videos? And the answer is directly no, because directly you can use it with images only. But in your application, nothing prevents you from splitting videos into frames and processing each frame independently. And that is something which happens when I run the application, because in the application, you see, it looks almost as it is a video. I can take a cup and then it changes the class. So essentially, you can always use classification on individual frames. Cool. So I think that you should be able probably to do that already by now. So let me do it as well here. I will click on Export TensorFlow JS model. I will select the right directory. The right directory is a little bit tricky thing to find. So demo 1, hack workshop, apps, web bootstrap, and then public, and then model. So I should export my model here. Should I delete the previous one? Probably I should delete the previous one before, in order not to get confused. So I will delete the previous model, and I will export the new model there. So a tricky thing here, it asks me, do I want to optimize before exporting or just export? So to make the model good, to make the model really accurate, you need to train it a little bit more. So the way it trained it here in the Lobe AI application, you saw that it happened very fast, right? As soon as we uploaded the images, some kind of model is already working. To make it better, we need to do optimize and export. So if we click optimize and export, it will start training the model better, and it will spend some time doing so. How much time? It depends. Like yesterday, for me, it was like half an hour. Sometimes it's faster. I don't want to wait for half an hour right now. And you also see there is settings. So you can say here, like, how do you want to optimize the model? You can provide some more settings. So in my case, I would say just export. But if you are creating your project for ImagineCup, definitely click optimize and wait for as long as it needs to train to get the better accuracy. So now it's exporting. So it also probably trains a little bit, but not a lot. So meanwhile, here is my command line. I can also name my project, because right now it says untitled, and that is uncool because now it's kind of confusing. I do not know what this model refers to, so I probably should have named my project somehow. Let me finish. Let me wait for export, and then I will rename it, not to confuse it in the middle of the export. Cool. So here is my directory entitled TensorFlow.js, and inside you can see I have those binary files similar to the ones that I had before. I have model.json, signature.json, and I also have labels.txt, and I have the directory called example. So I need to tidy up a little bit because it exported the model into the directory called untitled TensorFlow.js. And my web application does not expect this directory, right? So I need to move all the files one level up. So what I will do, I will delete the directory called example because I don't need it. And I will move everything from here to the parent directory. And I will remove this untitled TensorFlow.js. So here now I have all the files in place. Right, in the public model, I have the binary files and the description files, model and signature. And I can probably start my application. So I go back to the directory of application and I do yarn start. And we wait again. Are you following? Do you need to some more comments around like where to put the files? Was it confusing? Was it clear? How did I access training parameters while exporting? To be honest, I did not go into detail with training parameters. So the only thing you can do, let's see that again. So I say TensorFlow.js. I provide the directory. And then it asks me whether I want to optimize. And here there is this information, little information button. And essentially what it does, it's the kind of Q&A. How do I train for longer? And it says, do the file optimize model. Let's try to see whether we have file optimized model. So here is in the menu, it has optimized model. But it looks like there are no parameters. So the only thing you can do here is like, can I change my model architecture? In fact, you can change the architecture under file project settings. Let's have a look. File project settings. Only few settings like optimize for accuracy, optimize for speed. What it essentially means is that when I was talking about this convolutional neural network, you can use different networks of different size, of different complexity as the underlying feature extractor. So the one which is optimized for accuracy uses very big network. And that is probably the case right now with our model, because as you have seen, it contains a lot of those binary files. It means that our model is really big. It is bigger than the model which was used in the original application. And that's why it's also much slower. You see, right now, my application has already started, but the model is still loading because it is pretty big. Let us actually try to see how big it is. So 102 megabytes probably. Is it like that? So pretty big. And still training, still loading into the web application. So that is probably a huge model, and not it wouldn't execute very fast in the browser. So if we want to make it faster, we will change here optimize model. We'll do project settings. We'll do optimize for speed, faster, smaller, less accurate. We'll do reset training. And let's see how it affects the accuracy, because before it was something like 96%. You see, that is how fast the training happens behind the scenes. Now my computer is probably struggling. Yeah, okay, now this big model has loaded. No cap, cap, no cap again. So you see, I have replaced the model and I have made my application working. So my application is now different from the previous one, which was originally in the GitHub in the workshop. I just replaced the model. Now, if you want to turn it into the project that I was talking about originally, like counting how many times I drink the tea during the day, I would need to change the logic of the application. So right now, the only thing application does is change this the sliders, those sliders, right, with probabilities. So I would need to do something else. I would need to detect whenever the class changes, do the counter, and instead of those sliders, display the counter here, 1, 2, 3, 4, 5, how many times I drank tea. So that is, if you are familiar with Node.js, that is something you should be able to do relatively easily, right? I will not do that because I'm not very familiar with Node.js. I prefer other web development technologies like ASP.NET. You can, of course, do that in ASP.NET as well, but that's kind of not as trendy and cool as Node.js. Okay, so now let's try to make this model smaller, right? So let's remember how big our model was. You see, it was 25 binary files right here. I will remove them. And I will export the model again. So you see how dramatically the accuracy dropped. Now the cap is detected only correctly in 29% of the cases, which is really, really bad. So probably that was not a good idea to optimize the model for speed and not for accuracy. But who knows? Maybe if we retrain it again, maybe it will be better. And let me rename the model as well. So I would do it cap. I will name it cap detector. And I will export it as TensorFlow.js model. into the same directory. So I would say export, and I will say, should I say optimize? No, I would say just export. And you can optimize if you want, like after the workshop, when you have more time, you can play with it a little bit more. Now my T has finished. I should probably build into the model the predictor, like your T will run out in 35 minutes or something like that, so that I can proactively call my daughter to bring me the new cup of tea. Good. So let's now check the model. We need to again move the files from cup detector to the current directory. And remove cup detector and example. And I'm left, you see, instead of 25 binary files, we have only 4. So this model is significantly smaller, and probably it would be significantly faster to run. So let us try it again. But significantly less accurate. So there's always a compromise between accuracy and speed. And you should see, like, if you want the model to run in the mobile device to run fast, you would optimize for speed. If you want the model to run on the server side, for example, something is running on port 3000. Why something is running on port 3000? I thought I have closed that. Let's try once more. Hopefully it's not using my camera, meaning that the camera is not locked. Could be. So you see now it's loading, and it should be much faster than before. For some reason, it doesn't have access to my camera from this port. I don't know why it cannot access my camera. Probably the previous instance of the application is somehow left in the memory and is blocking the access to the camera. But I hope you get the idea. And we've seen that the model is smaller and it should run faster. So do you need any more time to experiment with it right now, or shall we continue? Let me know in the chat, like, what do you think? Are you still were you able to get the application, the renewed application running? If you have any screenshots, by the way, of the application that you have done, which is running in your browser, you can share the screenshots in the chat, hopefully. And that would be fun to see that you've done something real today. Anyone still alive? Anyone wants to continue? Okay, we have one person who got the application running, and that is great news. So another great news is that we have completed the official part of the workshop. So the official part of the workshop was this one: install Lobe and make it run, get the data set and train your model, and then integrate it into web applications. So that is what we have done today. And now you know how to start working on your Imagine Cup project. So if you can think of a great project with great idea around image classification, first of all, participate in the Epic with this idea to get the prize. Second, start with this with training Lobe AI application. Wow, so nice to see the screenshot in the chat. So is it panda versus no panda? Panda, cat, and dog. Excellent. That's a hard thing for a computer to classify, I think, sometimes. Okay, so if you want to do the great application, start with training the model in Lobe AI and getting this web application, sample web application running. And then you can build on top of it any functionality you need. So that is something we will not do today, but something you can do on your own. I will talk a little bit about hosting this application. So you can, first of all, you can host this application in Azure. Sorry, I want to cross out the static web app, because static web app you cannot host it in static web app because it's not static, it's not JS. So you can, first of all, you can host this application in Azure so that it's not running on your computer, it's available somewhere on the internet. So that is something where you will start needing our Microsoft Cloud. Then think of your own idea and submit it to Imagine Cup. To do that, to play with Azure, what you need to do, you probably already know what you need to do. Being a student, you can get $100 in free cloud credit. And by all means, if you don't have it, go and activate that. Another good way, by the way, to get free cloud resources is to get GitHub Student Developer Pack. I will show you, since I don't have the slide for it, I will just show you in the browser. If you look for, let me look for GitHub Student Developer Pack. You will need to verify again your student identity either by email or by providing some scanned document. But you see, you get like DigitalOcean, you get GitHub Pro, you get Microsoft Azure, the same student benefit here. You get some tools from JetBrains and from other companies as well. So it's a kind of one place where you can go, verify your student status once, and then get all those great applications and resources from different companies. So by all means, use that while you are a student. You see how many cool free things you can get as a student. Sometimes I actually regret that I'm not a student anymore. Okay, so with Azure, let's discuss a little bit how you can host this application in Azure. So with Azure, there are two ways you can use Azure. You can use it from web portal, or you can use it from command line. And actually, there is a third way you can use it from Visual Studio Code. And if I want to run this application from the cloud, I need to host the web application, right? To create a web application. The good thing about the cloud is that in the cloud, you don't need to think about the details. Like, for example, if you were trying to host this application in some kind of web provider, you would need to think like, I need to create a virtual machine. On the virtual machine, I need to install a web server and so on. With Azure, you just say, I want to create a web application, and that is because I need to host something on the web. So there are three things, again, you can do that. And the easiest way is to use command line interface. So AZ is the command you can use to control the cloud. It has a lot of options, like everything you can do from web interface and more, you can do through this AZ command. And to set it up, like if you don't have this Azure CLI installed, the good thing to install it is to use Python. So if you have Python environment, you can just say pip install Azure CLI, and that would install this command line interface and make this AZ command available to you. In my case, it's already installed. That's why it just checks that everything is in place. Then you would need to, when you use it for the first time, you would need to authenticate with your cloud. So once you get your free cloud, you install this AZ command, and then you say AZ login. You log in through the browser, and then this command kind of ties up to your cloud account, and you don't need to specify like those information during the additional, like each time you use it. And to start a web application, it's actually very simple. You say AZ web app up. So you want to bring up current directory as the web application, and then you see -n and create a name. So like in my case, it would be something like Lobe 13 and -g Lobe. -g is the resource group. Where do I want to place it? And that's it. I will not run it now, but actually let me see, because it has some kind of option not to run it, but just to verify that everything works. Dry run. So I can say -n Lobe 13 -g Lobe -- dry run. So this is really cool, because to create a web application, you don't need to bother at all. Actually, the way web applications work in Azure, it's a little bit tricky. So for each application, you have the application itself, and you have the app service plan, which is kind of virtual machine which corresponds to that application. But you don't need to worry about those details. Just say AZ web app up, and it will bring the web application up. So that's one of the options. If you know how to use command line, if you are really proficient, if you want to deploy like often many applications, it's much easier to do it this way. If you want, you can of course do it from the browser. So you can go to portal.azure.com, and you can say here on the portal, you can say, I want to create a web application. And that's it. You would say create a web application, and then it will give you some options here. Like, do you want to use ASP.NET? Do you want to use Java? Do you want to use Node? And you would want to use Node in our case, and so on. So you create this application, and then you deploy to it using some methods here. And the third way is through Visual Studio Code. Like Visual Studio Code, if you are not using Visual Studio Code, you should by all means use it, because that's the best code editor. And the good thing about Visual Studio Code is that it's really customizable. So if you just need to edit text files, you install Visual Studio Code. It's very lightweight. It doesn't contain a lot of things inside. It starts fast and it works perfectly. But if you want to use cloud, like if you want to host web applications, if you want to use machine learning in the cloud and so on, you can install extensions to Visual Studio Code. And extensions allow you to do many other things. Like, for example, in our case, extensions allow us to create web applications. So here I have Azure extension. And you can see it has functions, it has machine learning, and it has app service. And app service is exactly the thing needed for web applications. So it shows me in my subscription, it shows all web applications that I already have. It takes a little bit of time because I have quite a number of them. Okay, so yeah, here is my list of possible web applications, and you see each application has like databases, settings, and so on. Logs, you can check all that from here. And in your files, I opened our web application directory here, which contains my model, which contains like all our code. And I can just right click and I say deploy to web app. So you see, deploy to web app, I can create new web application from here, or I can use existing one. I will use existing one, Lobe 13. And I will say deploy. And it starts deploying. You can see that it does creating deployment, creating zip package. So it packages all the files into one big zip file, then it deploys it to the cloud, it expands it there, installs all the packages using Yarn, and then starts the application. And you can see how that happens here. It will take quite a long time, by the way. Hopefully, by the end of our workshop, we will see how this application runs in the cloud. Any questions that you have? I see that there is an interesting discussion going on in the chat about whether you need to submit only idea or the project itself. So in the Imagine Cup, we have like first thing called Epic Challenge. And Epic Challenge happens, I believe, pretty soon. And that is only the idea, but that is only a first step. You just get the additional possibility to get some prize, some fun prize for providing the best idea. And that's definitely a good way to test out your idea, because you will see how far it rates, what people think about it. And then after the Epic Challenge, or even regardless of the Epic Challenge, you can participate in the main Imagine Cup. And main Imagine Cup is about creating the actual project, the actual prototype project, which you can then turn into a startup, which you can then turn into a research project. So that is something you do as a team by hand using cool technology. And one of that cool technologies is, of course, Lobe AI, which we have discussed today. Let me also say a few words about other possible projects that you can use for image recognition tasks, which is called customvision.ai. Customvision.ai is the cloud-based object detection and the image classification tool, meaning that it runs mostly in the cloud. It doesn't allow you to export. Well, it does allow you to export a model for mobile device, but that is kind of not the main use for this project. The main use for this project is to create the service in the cloud, which will classify or detect objects in the image. And the way it works, let me open this cat detector, for example. It is a web-based tool, so you don't need to install anything. You just need access to the cloud. So you would to do things that I'm showing you now, you would need to create your own account, and inside that account you would need to create an object called custom vision, and then only the customvision.ai would work for you. So here what you can do, you can upload the images, and it supports, as I mentioned, two things. It supports classification. Classification is when you distinguish between two types of images, or two or more. And object detection is when you can actually detect the object inside the image. And this is, you see that this is the data set prepared for object detection, because you can see the actual head of a cat on the picture. So here you have the data set, for example, of 18 pictures. And for each of those, we have marked up the data set with the rectangle, with the bounding box. So now we can use this data set to train the model. And this model would probably detect us the pictures of cats. So let's try to take some pictures of cats from the internet. This one looks good. So I would take the URL from here, and I would paste it here, and let's see if it detects the cat. Yeah, it detects the cat with a probability of 61%. So once you have trained this model here, what you can do, you can use it as a web service. So you can call it from your application as the REST API. So here you have all the URLs. Like this is the URL. This is the how you would call this model, and from like any application, like from the cloud application, from mobile application, you can do this through the cloud, through the internet call to perform object detection or image classification on your data, on your image. So that is another way to approach image classification or object detection in addition to Lobe AI. Lobe AI is definitely easier. It is like fun to use. That's why we have seen Lobe AI in the workshop today and not custom vision, but custom vision is another great option, which you can definitely use as well. Okay, any other questions that you have? Any questions about Imagine Cup, about ideas that can win in Imagine Cup? We can also talk about that a little bit. Yeah, let's see, by the way, what happens to our application. Our application is still being deployed. Unfortunately, that's not a very fast thing to happen. Even though our model is pretty compact. So we have seen one screenshot from today. So if anybody else can share the screenshot, what you managed to do today, that would be great. We will be really happy to see a working application that you have created in less than 2 hours. You see, Lobe AI is so easy to use that we have spent, I think, less than an hour creating the application and more talking about like how computer vision works, how neural networks work, and how you can win in Imagine Cup, even though we haven't talked yet about that. Does anybody want to know how to win the Imagine Cup?
I feel like that's the ultimate answer. That's like, what's the meaning of life? Somebody out there has to have a good question for you. You gotta hand out that mentorship session too. We need some responses.
Yeah, I feel like Panda classifier does not yet qualify for the mentorship session. But if you turn this idea into something more, so to speak, Imagine capable, something which will excite the Imagine Cup jury. That would be definitely more interesting. Meanwhile, our application started deploying. Well, continued deploying. So we see something happening there. So the interesting thing is that you can take almost any like data that you can find. For example, if you find the data set with pandas, cats, and dogs, and you train this classifier, you can think about how to use that in real life. So probably you can think about some problems that pandas are having, for example, in the zoos, like not having enough sleep, for example. And then you can train the classifier of sleeping panda versus non-sleeping panda, and you can calculate the percentage of time it sleeps. And then, for example, if it sleeps less than it should, you can fire an alarm or send SMS to the zookeeper to alert that the panda is not feeling well. So that's just something you can build with image classification, which we have talked about today. Something which is useful and something which will solve some real-world problem. I'm not sure that there is a problem of sleeping panda, but that was just a simple example how to think in terms of applying this technology to some more specific real-world problems. Okay, the great idea we have in the chat is of creating productivity calculator for college students who get distracted in online meetings. So which detects how much time you actually focused on your lecture. That's a great idea. Technically speaking, there might be one small problem there because your camera is shared between like the camera is exclusively used by your application. So if you are not using any clever techniques, then for example, if you are in an online meeting in Zoom or Teams call, then your other application would not be able to access the same camera. So you either need to do some clever trick how to overcome that, or maybe position this not as the software project, but as the hardware project. So for example, you can even build a small device which you just put on your table. It looks at you and then it's like alerts you each time you are not concentrating. For example, each time you look away from your screen, it does a beep, for example. That might be another cool idea to position it. And or it can be like regardless of online meetings, it can be a device that monitors your video feed constantly and alerts you whenever you are not concentrating enough, not looking at the screen enough, or something like that. That's a good idea indeed. So if we do not have any other better ideas, that would, I guess, qualify for a mentoring session. If you develop this idea further at some point during Imagine Cup, in Imagine Cup Discord, you feel free to ping me, and yeah, we can talk some more about this idea or about some technical implementation. So overall, you can think about Imagine Cup projects in several different ways. For example, one of them would be creating or thinking of it as a startup, right? For example, a device that alerts you whenever you are not attentive. That might be a great device to start up using Kickstarter or some other crowdsourcing platforms, crowdfunding platforms, right? That is a good example of Imagine Cup project which leads to a startup. Another good example is a project which leads to something good, like detecting pandas pandas that don't sleep enough. That is something which can be used in the zoos to make the pandas world better. So that is another great type of Imagine Cup project. Okay, we now have deployed our web application, so we should be able to see how our project now works in the browser. So it was called Lobe 13 asiawebsites.net. Now the model takes a little bit more time to load because it's loading over the internet, not from my local computer to local computer, and it's still working. So not very accurate because it alternates. You see, sometimes it does not see the cup properly, but most of the times that it doesn't see the cup properly. So, but it probably can detect if I'm not present. So this is empty. That is again me without the cup. So you see, today in under 2 hours, we managed to start from absolutely zero. We didn't even have images. We took images using Lobe AI. We trained the model. We took the sample web application, put our model inside that application, and deployed that application to Azure Cloud. Essentially, we have done a small project which probably would not win the Imagine Cup, but which definitely can be a first starting point on which you can build something more interesting on top. And that something interesting probably can win Imagine Cup. So I definitely wish you luck in Imagine Cup. Definitely do not forget to register and take part in this competition, because that is great fun for you, great experience, something you can put on your resume, and maybe that's something which will result in you creating a great idea and making the world a better place. Thank you. Any final questions, thoughts? I would be glad to answer. Something you want to hear from us?
Dmitry, I know you've mentored a ton of Imagine Cup teams in the past as they've made it to later stages. What advice would you give students to think about, especially starting so early, to really help them get further in the competition instead of just building something, but thinking about something impactful?
I think the main advice I can give is to enjoy every moment of it, because there are actually two possible ways to approach the Imagine Cup, and one of them is to like go for winning the Imagine Cup. That is the hard way. It requires a lot of energy, efforts, time, and so on. And it can be a little bit disappointing because not everyone wins. But it is definitely, it should not discourage you from taking part in the Imagine Cup. And the second approach is enjoying the process. And because the process is really enjoyable, when you create your own idea, when you start seeing how this idea comes to life, that is something really inspiring. And that is something which is important for your career, because you start enjoying like this creativity, putting something together, working as a team, something you do not always have in the university when they ask you to work on some specific projects. So definitely enjoy it. Another useful advice, do not go too deep into architecting things, because you can spend a lot of time creating ideal architecture and making everything so perfect. And you will spend a lot of time, but you would not have enough time to, finalize the project or add some features that are really impactful. So think about like what would make the most impact to the judges. What is the most interesting feature of your application, and do this as the minimum viable product (MVP). So spend the time on something which will impress people when you show it to them. I guess this can be summarized as focus. So enjoy, focus on important things, and make the most of it. Like put it into resume, apply to some other contests as well, because Imagine Cup is not the only place you can present your project. So start doing something, be active, and that would lead you far. Yeah, great comments, Anupam. So you can, in fact, build the same model with TensorFlow, because Lobe, behind the scenes, Lobe has the same kind of idea of transfer learning, but it makes it very simple. Of course, when you build the model yourself, you have a lot more control over different parameters. And you can also retrain the convolutional base a little bit. So if you train your own model properly, a good data scientist can train it better than Lobe AI. But like the majority of people who do not know what they are doing, who are not advanced enough, for them Lobe AI makes it really effective.
And then Dmitry, if students have additional questions moving forward, like they think of one after they go to sleep tonight or something like that, you'll be in the Discord throughout the Imagine Cup?
Sure, I think that's the best play for them to go after this this event today, and hang out in Discord. That's a great place to meet us, to ask any further questions, and really take the most of the competition.
Cool. Sounds great. And so students can come to you for, obviously, for Lobe stuff, for AI stuff. What else can students come to you for?
Actually, for any advice on the competition as well, like what is the most important thing to focus on, how do you like the idea, those kind of things as well.
That's great. So kind of giving students that opportunity to get early feedback and kind of make sure they're headed in the right direction. Because once you're down a path, it's much harder to turn around. But if you're kind of trying to choose a path, then that's the best time to get the advice.
Yeah, actually, I think maybe we can think about creating a channel or something like that, where different people can give their opinions, so that they can get not only like my advice, but a view on the idea from a bunch of people. That would be even more useful.
Yeah, for sure. And we're gonna also, we have a professional skills. Sorry, we have a professional skills. Thank you. Channel as well. So if students are wanting advice on how to actually like tell the story of what they're creating and those sort of things, it's also a great resource for them.
Yeah, I think Discord is a great place to keep in touch. It's also very well structured, so you can find the place where to ask a question, and you would get really, hopefully, good response.
Sounds good. Well, thank you so much, Dmitry. Really appreciate you doing the session today. And I know it's probably your bedtime in Russia, so thanks for staying up with us.
That is true. That was my pleasure. Thank you for everyone who joined this session. I hope it was useful to you. And yeah, don't stop there. Continue your Imagine Cup journey as far as possible, hopefully to the victory.
Thank you.
There is actually one question we have about how well does Lobe AI works with highly delicate medical-based data. And the answer here is it's not so much about Lobe AI. First of all, when you start dealing with the medical data, you should consider like overall like how ethical it is, how you would use it, because there are some usages of AI which should be which should be like seriously considered. Like, for example, you should not take the diagnosis based only on the decision of a neural network, because neural network cannot be 100% accurate. So you should only very carefully use AI as the supplement in making a diagnosis. So that is the first thing to think about. And then in terms of actually working with data, Lobe AI is the client application. So your data does not leave the device; it stays locally with you. So you are not, you don't have any problems like that. You are transferring the data to third-party servers. Unlike custom vision works on the server side. Well, it can also work in container on the client side as well. So if that is really something you need. In terms of accuracy, like as I mentioned, if you train your own custom model, you are likely to get higher accuracy, especially with the data like medical data, because medical data is not similar to like traditional pictures that we have in the image data sets. And because Lobe AI using transfer learning from traditional image data sets, it works best with those kind of images, like similar to different objects around us, those kind of things. And medical data can have slightly different features. So for really, really important and highly sensitive, and when you need high accuracy with strange, some kind of non-traditional data, it's probably better to use Lobe AI only as the first starting point, like see if it allows you to get some accuracy and then improve it by creating the custom model. In principle, theoretically, it should be possible to take Lobe AI model and further fine-tune it. But I guess that would be more difficult than creating the model in TensorFlow from scratch. So if that's something really, really like highly specialized, like medical, for example, CT scans, for that it's probably better to create your own TensorFlow model. Yeah. And think about how you would train it, because normally you might not have a lot of data for your own specific scenario. So maybe you would need to do your own transfer learning based on some existing data sets and then specializing it to your own task using your own data, something like that. But that is something definitely you can ping me on Discord, because I can share some further ideas on a specific problem. Okay, thank you so much. If there are no further questions right now, then I think we will finish this session. And yeah, stay in touch on Discord. And thank you for being with us for whole 2 hours.